Hello everyone. Today I'll be talking regarding how AI starts talking with another AI. A few years ago, when someone said AI, most people imagined a chatbot. You type a question, it gives an answer. Very impressive, but also very passive. Today we are building something different. We are building AI systems that can plan, call tools, retrieve data, delegate tasks, and even talk to other AI agents. In other words, AI is moving from answering questions to executing workflows. And that raises a fascinating question: how AI starts talking to AI. Let's take a look of the AI of yesterday. AI used to work alone. As I said, you went to ChatGPT, you ask a question, it gives an answer. It doesn't have much coworker to work with. Now today, we are under AI evolution. We are seeing AI evolution. This slide may look like three separate columns, but they are really three ways to understand the same transformation. AI is evolving from simple prompt response systems into engineered agentic systems. In the early days, we focused on one question: how do I write a better prompt? Today, the question is much bigger: how do I design a reliable AI system? Towards the left, we see that how AI engineering is getting maturity. First came prompt engineering. We learned that the way we ask a question changes the quality of the answer. Then came context engineering. We realized that a good prompt is not enough. The AI also needs the right background information. Then memory engineering became important. If every conversation starts from zero, the AI cannot truly behave like an assistant or an agent. Then we moved to agent engineering, where AI is no longer just answering, but planning, choosing tools, and taking action. And finally, we arrive at system engineering. At this stage, we can see that how an AI system can perform in system level. The future of AI is not just better prompts. The future of AI is better architecture. Let's look at the middle column. The middle column explains why context engineering matters. When we talk to AI, we often think the prompt is the full instruction. But in enterprise AI, the prompt is only one small piece. A useful AI system may also need the user profile, previous conversation history, retrieved documents, business rules, and current data. For example, if I ask, what should I do next? The AI cannot answer well unless it knows my role, my project, my previous decisions, and the latest source data. So the smartest model in the world can give a poor answer if we give it poor context. Context engineering is the art of giving AI the right information, not all information. And this is also where RAG, or retrieved augmented generation, becomes important. Instead of relying only on what the model already knows, we retrieve the right documents or data at runtime and add them into the context. Now let's see the right column. This is the agent runtime flow. What happens when AI becomes an agent? A human does not simply give a prompt anymore. A human gives a goal. The planner agent breaks that goal into steps. Then specialized agents may help. For example, one agent may look at code, another may look at documentation, and another may review the final result. The agent then uses tool calls. This is also very important. A tool call is how AI interacts with the outside worlds, APIs, documents, ticketing systems, databases, or other applications. After the tool call, the agent observes the result and decides what to do next. That observe and act loop is what makes an agent different from a chatbot. A chatbot responds, an agent acts. The model is the brain, but tool calls are the hands. So the way the three columns converge together is the left column shows the evolution of AI engineering. The middle column shows how we construct better context. The right column shows how that context is used inside an agent runtime to plan, call tools, observe results, and take action. So engineering maturity creates this architecture. Context gives the AI the knowledge. Agent turn that knowledge into action. When these pieces come together, AI moves from being a smart text generator to becoming a working system. We talked about tool calls in the last slide. So tool calls is like giving AI its hands. If the language model is the brain, tool calls are the hands. The model does not directly access Jira, GitHub, Confluence, or any database systems. Instead, the application exposes approved tools with defined schemas. The model decides, I need to call this tool, but the application controls whether that tool is actually executed. That separation is critical for governance. We will talk about governance later in the slides. We should never give AI a credit card or admin access or a vague instruction like optimize the business. Let's look into MCP. MCP is similar to an USB-C port for AI tools. The challenge is that every enterprise has many systems: Jira, GitHub, Confluence, Slack, Teams, databases, file systems, cloud platforms, internal APIs. If every AI application builds custom integrations to every system, the architecture becomes messy very quickly. That is where MCP, Model Context Protocol, comes in. MCP gives AI applications a standard way to connect to external tools, data, prompts, and workflows. Think of it as a common plug and socket model for agent capabilities. MCP is not the brain, MCP is the connected layer. The agent decides what it needs. MCP helps it discover and invoke the right capability. Skill files. It's like giving agents the playbooks. But giving an agent tools is not enough. Imagine hiring a new employee, giving them access to every enterprise system and say, good luck. That would be chaos. Agents also need instructions, policies, procedures, examples, and boundaries. That is where skill files come in. Tools give agents capabilities, skills give agents discipline. That is how it helps the system to work. Let's move on how to build agent-to-agent communication using all the concepts that I talked earlier. Once agents have tools and skills, the next step is agent-to-agent communication. Instead of one giant agent doing everything, we can create specialized agents. The supervisor agent receives the goal. It delegates work to specialized agents. Each specialized agent performs a task. Then the supervisor combines the results. It starts to look less like a chatbot and more like a project team, except nobody complains about meetings. So far, I have talked about the good sides of building an AI system engineering. Now let's look at the risks. Prompt injection in agent systems. One of the biggest challenges in modern AI systems is prompt injection. In simple terms, it happens when AI receives instructions inside information it is processing. So say for example, the document, it receives a document. Document is the data for the AI, but the AI may mistakenly treat it as instructions. A bad AI doesn't have to be smart. It only has to convince a good AI to do something foolish. So take an example of an infected employee. Think of an organization. One employee receives bad information. They share it with another employee. That employee shares it with another team. Suddenly, an entire organization is working on false assumptions. AI systems face similar challenges. As we are building agent-to-agent communication, prompt injection is becoming a threat. A compromised agent can become the source of bad decisions throughout an agent network. So not everything an agent hears is something an agent should obey. This is where we are feeling the importance of guardrails of AI systems. AI Gateway is the form of giving guardrails to AI systems. It's like the enterprise control tower. This is why guardrails are becoming one of the most important areas in agent design. Guardrails ensure that if we are going to let agents call tools, talk to systems, and possibly talk to other agents, we need a control layer. That control layer is the AI gateway. So what does AI gateway do? Before accepting instructions, agents should verify the identity. Who sent this request? Authorization. Are they allowed to request this? Context. Does this instruction align with my mission? Policy. Would this violate rules? Human approval. Should a human approve this first? So here comes that security principle once again. In cybersecurity, we learned never trust user input. In agentic AI, we may need to learn never trust agent input either. Now we have to think about backup option for reliability. What if the agent is down? Then we have to have a backup agent to do its task. If one AI goes down, say for example, we work with humans. Normally a human coworker might cover for another human. In today's AI systems that we are building, we have to build similar behavior. One AI may be working in Azure environment, a backup AI may be running in Google Cloud. If one becomes unavailable, another takes over. Just like having a backup teammate. That's not science fiction. That's engineering. The application should not need to know which model is serving the request. It calls the AI gateway. The gateway decides whether to use the primary model, fallback model, or a different retrieval path. In agentic AI, reliability is not just about the model. Reliability is about the architecture around the model. So, in conclusion, how the AI journey is looking like in a nutshell. So, what happens when AI starts talking to AI, or how AI starts talking to AI? We move from a world of single chatbots to a world of agentic systems. Systems that can plan, retrieve, act, delegate, review, and recover from failure. But this future will not succeed just because the models are powerful. It will succeed only if the architecture is responsible. We need tool governance. MCP. MCP helps standardize how agents connect to tools. But MCP doesn't mean every instruction should be trusted. Skills. Skills define what an agent is allowed to do. They act like operating procedures. Memory. Memory should remember facts, not blindly remember malicious instructions. Context engineering. Context engineering is not simply adding more information, it is adding the right information while filtering dangerous information. So, good context helps an agent think. We need AI gateways. It can inspect requests, filter content, enforce policies, monitor tool calls, and prevent unsafe actions before they reach another agent. We need observability. And most importantly, we still need humans in the loop for judgment because the goal is not to build AI that talks to other AI endlessly. The goal is to build AI systems that help humans get better outcomes. Thank you.